Okay, now in this video, I want to explain to you the nuclear charge, effective nuclear charge, and shielding effect. Okay, if you look at the periodic table, what I want you to notice is when we are going down any group, okay, go down any group, you go down any group, okay, any group, you go down it. What I want you to notice is the number of protons is increasing. Okay, let's say, like, for example, this group here, right? 22 protons, oops, too big. 40 protons, 72 protons, 104 protons. 26 protons, 44 protons, 76 protons, 108 protons. 7 protons, 15, 33, 51. The number of protons are increasing when we go down any group. Okay, I hope you notice that. Now, protons, what they do is they pull electrons to the center. That means they're pulling all of the electrons. So if you imagine that's okay, so let's say that's the nucleus, right? So the protons in the nucleus, their job is to pull everything towards the center. That's what they're doing. So they're pulling everything to the center of the nucleus. That's what they're doing. This attraction is called nuclear. Oops, what's happening? This attraction is called nuclear charge. That is what it's called. Okay, nuclear charge, and the symbol for nuclear charge is Z. So all the electrons are being pulled to the nucleus by the protons. This is called nuclear charge. Okay, that's number one. The other thing I want to tell you is, okay, let's erase this first. The other thing I want to tell you is, as we go down the group, what I want you to notice is the number of shells are increasing. Like, for example, in hydrogen is 1 shell. Lithium has 2 shells. Sodium has 3 shells. It's getting bigger. Potassium has 4 shells, right? Potassium has 4 shells. So 1, 2, 3, 4. Potassium is 4 shells, right? So what I want you to notice is it's getting bigger. Okay, it's getting bigger. More shells are being added. Okay, more shells are being added. So the distance from the nucleus, okay, the distance from the nucleus to the valence shell is getting bigger. See, the distance is getting bigger. Okay, so the radius is getting bigger from the nucleus to the valence shell, the last shell where the electron is. Okay, that's another thing I want you to notice. When you're going down a group, that is what is happening. Okay. Then another thing that I want you to also understand is when we go down a group, right? What is happening is, let's say you have shell number 1, okay, and then you have shell number 2, and then you have shell number 3, and let's say you have shell number 4. Okay, so what is happening is there are electrons in shell number 1. There are electrons in shell number 1. Okay, there are electrons in shell number 2, there are electrons in shell number 3, there are electrons in shell number 4. Okay, so what is happening here is, if you put it this way, okay, I should have changed the color just now. Okay, so let's change color for each one. Okay, so let's say this is red, let's say this is green, let's say this is purple, and let's say this is pink. Okay, so those are pink electrons, purple electrons, and green electrons. So what I want you to notice is this: the red electrons are inside, right? So it keeps going like that. Okay, so what I want you to notice is this: the green electrons, which are the closest to the nucleus, what's happening is they are shielding. So the word I'm trying to introduce to you is called shielding. S-H-I-E-L-D. Shielding. Okay, shielding. So if this is the nucleus, right? If that's the nucleus, and let's say this is the valence electron. Okay, let's say that's the valence electrons. So between the nucleus and the valence electrons, there are many other electrons in between. Okay, there are many other electrons in between them. Okay, so these electrons are all in the inner shells. Okay, maybe shell number 3, maybe whatever shell, there are electrons. So what is happening is these electrons are, the inner electrons are shielding the green electron from the nuclear charge. That means the nuclear charge cannot act on the green electron, which is a valence electron, very strongly, because the electrons which are in between them are shielding them. Okay, shielding the green electrons. So the red electron, the purple electron, the yellow electron is shielding the green electron from the nuclear charge. So okay, so the green electron is not feeling a very strong attraction. Okay, it's not feeling a very strong attraction. So let me just do this one more time for you. Okay, let me just do this one more time. Okay, let's erase this. Okay, so let's say this is the nucleus, right? Let's say this is the nucleus, right? So closer to the nucleus, you have red electrons, let's say, and then further a little bit, let's say you have green electrons. This is shell number 2. Shell number 2 is 2s2. Okay, so you have green electrons. Let's say you have green electrons here. Further away, then you have the third level. You have these electrons here, the purple electrons, and then so let's say the last shell is the yellow electron. Okay, so this is the last shell. Okay, so let's say that's the last shell, right? So what is happening here is the nucleus is trying to attract the electrons. Okay, so it's attracting all the electrons. This yellow electron, the last shell, which we call the valence electron. Okay, valence electron. What is happening is these two red electrons, right? They are shielding the green electrons from the attractive force of the nucleus. Okay, so the green electrons are feeling less attraction compared to the red ones. Then what happens is the green and the red are shielding the purple electrons from the nuclear charge. Okay, let's say these white lines are the nuclear charge. So the red and the green are protecting the purple electrons from the nuclear charge. And then all of the red, the green, and the purple are shielding the yellow electron, the valence electron, from the nuclear charge. So this is called shielding effect. Okay, where electrons in the inner shell are shielding electrons in the outer shell. Okay, so when we look at the periodic table again, what I want you to know is this. Okay, this is what I want you to know. I want you to know, when we are going from the top of the periodic table to the bottom of the periodic table, I want you to know nuclear charge is increasing. Okay, why is the nuclear charge increasing? Because protons are increasing. Okay, that's number one. Then another thing I want you to know is shielding effect is increasing. Okay, and there are two reasons why shielding effect increases. First reason is this more shells. Okay, more shells, and so distance is greater. Second reason is inner shell electrons. Okay, inner shell electrons shield electrons placed in higher energy shells. Okay, two reasons. So what is happening is when we go down, yes, nuclear charge is increasing. Okay, so electrons are feeling stronger attraction, but shielding effect is increasing much more. Why? Because there are more shells, so the distance is increasing, and the inner shell electrons are shielding the outer shell electrons. So what is happening here has a summary. The effective nuclear charge felt by valence electrons is getting lesser and lesser as we go down. Okay, as we go down. So that is what is happening. Meanwhile, when we go across, okay, we go across like this. Okay, so let's do this clear page. Okay, oops, I cleared everything. Okay, now as we go across, right, when we go across, what I wanted to notice is, let's say we take period 3, right? I want you to notice the number of protons are increasing one at a time. Okay, one at a time. 13, 14, 15, 16, 17, 18. It's increasing. So when we are going from left to right, what is happening here is Z is increasing. Okay, the nuclear charge is increasing. But I also want you to notice that sodium is 1s2, 2s2, 2p6, 3s1. Aluminium is 1s2, 2s2, 2p6, 3s2, 3p1. And then let's say we take phosphorus. Phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. And then let's take the last person here, argon. Argon is 1s2, 2s2, 2p6, 3s2, 3p6. What I want you to notice here is the number of inner shells is the same. Okay, so there is shell number 1 and there is shell number 2. And then this is the valence shell, the last shell. Okay, or shell number 3, the valence shell. So all the elements in the same period, they have the same number of inner shells. Like in this case, there is this shell and this shell. That's it. All of them will have the same amount. So when we go across a period, what I want you to know is the shielding effect is constant. It's not changing so much. Okay, it may change a little bit, but not so much. And so the ZEFF acting on the valence shell is increasing. That means the valence shell electrons are gradually feeling a greater amount of attraction as we go from left to right. Okay, because the protons is increasing, but the shielding effect is the same because the number of inner shells is the same. And so the ZEFF, or the effective nuclear charge experienced by the valence electrons, is getting more and more. And that is why as we move to the right hand side, the size also gets smaller. So in this video, I just want you to understand two things. Okay, two things. Going down, what is happening? Proton, this is increasing, shielding effect is increasing much more. And so ZEFF on valence shell is decreasing. When we go this way, Z is increasing, shielding effect is constant. ZEFF on valence shell is increasing. Okay, there's two things I want you to know. These are the trends in the periodic table. So going down, electrons are being gradually weakly held. Going from left to right, they're gradually being held strongly. Okay, so this is important. So then next we'll just look at the trends very quickly and then we'll be done. Okay.